Okay, we just saw how to work a future value problem. So we looked at an example where you put $100 in today and it grows for 3 years at 10% and you figure out how much will be there at the end. Now let's turn that problem upside down and let's see if we can solve it the other direction. You see, in the previous case, we were going from a present value forward in time, solving for the future value. That is called compounding. But in this case, we're going the other direction. We're saying that we know we want to end up with $100 3 years from now, and the interest rate is 10% per year. So how much would we have to put in today to make that happen? In other words, what's the present value of a $100 cash flow that isn't going to occur for 3 years if the interest rate is 10%? This process, going from future value back to present value, is called discounting, and that's the opposite of compounding. Well, the good news is that this is actually very easy. We just have to turn things around. So you remember this formula? The future value equals the present value times 1 plus I to the n. We can simply turn that around and solve for the present value. So we need to get rid of this factor, this 1 plus I to the n factor on this side of the equation. How exactly would we do that? Well, since it's multiplied on this side of the equation, I guess the inverse operation would be to divide it. We got to divide both sides by 1 plus I to the n. And if we divide the right side by that, it's going to go away from there. And if we divide the left side, then we're going to end up with future value divided by 1 plus I to the n. And that's correct. That's exactly what we want to do. You should know this formula very, very well also. So if you're going from future value back to present value, the way you do that is to take the future value and divide by that factor 1 plus I to the n. Remember, in the previous case, when we were going the other direction from present to future value, we took the present value times that factor. But now we're doing the inverse operation. This is pretty easy here. We just take the future value of $100 and we divide by 1.1 to the third power. So that's easy on either a graphing calculator or a non-graphing calculator. 100 divided by 1.1 to the power of 3 gets us $75.13 for the present value. We could also do this on a TI BA2 Plus. We could take our $100, that's the future value, but then we want to go back to the present, divide by 1.1 to the power of 3, and that's going to give us the $75.13. And you know this is true. You can check it. You can see that if you started with this amount of money, $75.13, and you invested that for 3 years at 10% interest, you would end up with $100. And you can try that to actually verify that it works. So under an interest rate of 10%, a person should be equally happy getting $75.13 today or getting $100 3 years from now. Okay, again, there is a calculator method for solving this problem, but I'm not going to get into the calculator shortcuts just yet because you really don't need to for that sort of problem. It's not that difficult to just do it using the equation. Alright, let's do a little something else. Let's say that you know the present value and you know the future value, but you don't know what interest rate you're actually earning. Okay. So here's an example problem. Let's say that you want to know what interest rate you'd have to earn to go from $100 now to $125.97 in 3 years. Alright, so in this case, we know the present value, we know the future value, we know the value of n, that's 3 years. We don't know what the interest rate would have to be in order to make that happen. Well, let's see how we might go about that. Okay, first thing I'm going to do is go up here and start with my good old future value formula again. I'm going to make a copy of it there. And the trick is I want to solve for I. I want to solve for the interest rate. Well, the first thing I need to do is divide out the present value from this side. Okay, if I divide the present value, it goes away from here, and then it ends up on this side of the equation. I've got future value over present value over there. Okay, the next thing, and this may be a little tricky for some people, is how to get rid of this exponent of n. You cannot simply divide it. But here's what you can do. You can raise this expression to the power of 1 over n. And when you have consecutive exponents like this, then they do in fact multiply. And n times 1 over n is just going to be 1. So the result of all of this would be that on this side you're going to have 1 plus I to the power of 1, which, as you should know, is just 1 plus I. So we can even get rid of the parentheses. Now don't forget, over here you have to actually raise that to the power of 1 over n so that you're doing the same thing to both sides. Then the last operation is to go ahead and subtract off this 1, and now you've got the solution. The interest rate can be found as future value over present value, raise that to the power of 1 over n, and then subtract 1. How do we do that on a calculator? Well, we'll go ahead and do this on a graphing calculator first. We'll take 125.97 divided by 100, because that's future value over present value. Then we're going to raise that to the power of 1/3, and then we're going to subtract 1. And we get basically 8%. That's the answer. Now let me show you a pitfall, a mistake that a lot of people make on this sort of thing. Some people will say, okay, we've got 125.97 divided by 100, and then we'll raise that to the power of 1/3, and then we'll subtract 1. And they get this answer, which is nowhere near correct. What went wrong? Do you see it? We didn't put the parentheses around 1/3. Why does that create a problem? Well, if you think about it, graphing calculators know the order of operations. They take care of anything in parentheses first, of course, but then after that they do exponentiation first, then they do multiplication and division. So literally the calculator interpreted this as to do this part first, which is fine, and it would have gotten 1.2597, and then it takes that answer to the power of not 1/3, but to the power of 1. And then it takes that answer and divides by 3 before subtracting 1, and that's not what we're looking for at all. That's the wrong way to do it. So it is very important, if you're going to put in an expression like this, to make sure that if you've got a fractional exponent like 1/3, put it in parentheses so that you'll get the right answer. Alright, now let's do this thing on a graphing calculator as well. We'll go ahead and clear this out, and then you can take 125.97 divided by 100, and hopefully you can see that, since you're just moving the decimal point over, that that's 1.2597. If not, you can go ahead and divide it out and you'll get that answer, of course. Okay, so 1.2597, and you're going to raise that to the power of what? 1/3. Now how do you get 1/3 on the display? You actually don't have to use these parentheses, and in fact I kind of prefer to avoid that when possible on this non-graphing calculator. So one way to get 1/3 up on the screen is to simply type 3 and then hit this reciprocal button, 1 over x, and that converts to the decimal form of 1/3. So you've got that, then you can subtract 1 if you want to, and that'll show you clearly the answer is about 8%. Okay, very good. So that's how you solve it using a formula. The next thing I'm going to show you is how to use the calculator shortcuts, because in this case I would understand if maybe you didn't remember this formula exactly. Now, the present value and future value formulas that we looked at earlier, I want you to know those without really having to think about it. So these two formulas, you need to know those. This one, it's helpful perhaps if you know it, but I would understand why not as many people might remember those. So let me show you how to use the calculator shortcut keys to solve this problem. We'll begin with the TI-BA2 Plus. Okay, the shortcut buttons are located on the third row of the calculator keypad, and each one of these represents a key variable that often pops up in time value of money problems. There's N for the number of periods, I for the percentage interest rate per period, PV for a present value, payment for a recurring cash flow that happens every single period, and then FV, of course, for future value. Now, each one of these represents, if you will, a slot in the calculator's memory. You could think of it as an address or a register or something like that in the memory where a value is held that corresponds to these 5 quantities. And if you have any old numbers that are hanging around from previous problems that you've worked, they actually stay in the memory. So if you put a value into one of these memory slots, then it actually stays there. Even if you turn the calculator off and come back weeks or months or even years later to turn it back on and continue working with it, it will still be there in the memory. The only way that a value ever gets cleared out of one of these registers is, number one, if you overwrite it with something else. So let's say that I put 7 in for the number of periods and then I decided to put 9 in. Well, the new value would replace the old value. Another way would be if you change the batteries or reset the calculator or something, which happens very, very rarely. And then the other way is if you actually tell the calculator to clear it all out. And so that's what I recommend. Before you start any problem like this, go ahead and get in the habit of clearing out these 5 registers. So we'll press the second key and then clear time value of money over here on the far right. We're going to begin by putting in the quantities that we do know and then asking the calculator to solve for the quantity that we don't know. So we'll begin with N. I guess we'll just work left to right. And there are 3 periods in this problem, so we type in 3 first and then we push N. Okay? Make sure you don't do N and then 3. It's got to be 3 and then N, because whatever's on the screen at the moment you press N, that's what goes into that little memory slot. Okay, I is the interest rate per period. We don't know that. That's the unknown in this problem. PV is the present value. So that's the initial cash flow, and we're going to put that in as 100 with a negative sign. I'm going to change that to a negative number and then put that in for PV. I'll come back to why it's negative here in just a minute. Payment, there's nothing like that yet. That would require there to be a cash flow that is recurring, that happens every single time period. We don't have that yet. Future value is obviously the 125.97, and that is not going to have a negative sign on it. So 125.97, there's the 7, and we push future value and it's in the memory. Now, why did I put a minus sign on one and not the other? You have to think of it in terms of direction of the cash flow. A cash outflow should have a negative sign on it. A cash inflow should have a positive sign. And in this situation, you're investing $100 up front to get $125.97 later on. So investing something means that the money comes out of your pocket today. You forego that money today. So that should have a negative sign on it. Whereas on the future value, it's positive because you get that money back from your investment. It's flowing back into your pocket. Okay, so if I do that and I compute the interest rate, then I get the 8% that I was expecting. So this is correct. This is what we wanted to see. And notice that this is actually written in percentage form on the calculator's display. It's written as 8, basically. It is not written as 0.08. When you're using a mathematical formula, then things will show up as 0.08, like so. Okay, 1.08 minus 1 is 0.08, and that was 8%. But when you're using specifically these calculator shortcut buttons, then it goes in there in percentage form, and you have to be careful to remember that. Now, one thing that you also have to be careful about is that minus sign issue I just mentioned. What would happen if you didn't put the minus sign there? What would happen if instead of putting minus 100, you put in just 100 for your present value, and then you tried to go ahead and compute that interest rate? Okay, this is what would show up on your calculator display. It's a friendly error 5 message. And most people would find that extremely frustrating because error 5 doesn't tell you anything about what's really going on. You just know that something is messed up. Well, let me be the first to tell you, I've seen many error 5 messages before, and I continue to make these errors even myself from time to time. So it's no big deal. The error 5 message just means that you left off a minus sign somewhere. Fortunately, it's very easy to fix. All you've got to do is hit the clear button, and you go back out to the main screen. Everything's still in the memory, so you don't have to replace anything except for this present value. Just go ahead and say, oops, I should have made that a negative value, and so you'll type in 100 with a minus sign, put that into present value, and then go ahead and recompute your interest rate, and it'll be just fine. I just wanted you to be aware of what happens when that message shows up, because chances are at some point you'll make that mistake, you'll see that message, now you know that it's not a big deal and you know how to fix it. Okay, let me show you how you can do an equivalent shortcut thing on the graphing calculator. The graphing calculator is actually equipped with the equivalent of these 5 buttons on the TI BA2 Plus, but you have to know where to find it. So here's how you do that. You start with the Apps button on the menu. Okay, that's for applications. Typically the first item on the Apps menu is Finance, so you can select that by either pressing the 1 or hitting Enter when it's highlighted. Okay, then the first item on the Finance menu is the TVM solver, or time value of money solver. You hit that, and this is what will come up. There may or may not be some values already in here, but that's okay because you're going to put the correct values in anyway. So we're going to put in 3 for the number of time periods. We're going to put in negative 100 for the present value. We're going to put in 125.97 for the future value. We're going to make sure that payment is 0. And then as for these other things, P/Y and C/Y, those should be pretty well set to 1 all the time. There are cases where someone might be able to do something with them set to other values. I don't really mess with those. And throughout the entire course, it's easiest to just set those to 1. And then as for this payment thing, end versus begin, it doesn't matter for this problem, but most of the time that should be set to end. And so you should probably make sure that it's there, and if it's not, go ahead and put the cursor on end and push the enter button just to make sure. And then if you ever need to change it to begin, it's easy to do so, and I'll show you that later. Okay, so you come up here to the interest rate and you push alpha. See the alpha button near the upper left corner? and then solve, of course, which is over here, shares the enter key, the lower right corner. And you get your answer. The percentage interest rate is about 8%. Okay, now there's one more variable that we still haven't solved for in the future value formula. Let's take a look. Okay, remember this is our future value formula. We have solved for the future value, we've solved for the present value, and we've solved for the interest rate. But sometimes we know those three variables, and the unknown is actually n, the number of time periods. So how would we go about solving for the number of time periods when the rest of the variables are known? Well, let me start by getting a copy of this equation down here, and then we'll go ahead and manipulate it so that we eventually solve for n. The first thing we got to do, as before, is go ahead and divide out this present value. So it goes away from this side because it was multiplied, and then on this side of the formula it's now divided. Alright, so now I've got future value over present value equals 1 plus I to the n. And in fact, I was at this step in the previous variable when I was solving for I. How do I get this n down from its exponent position? This is where it gets a little bit interesting. I can't really raise to the power of 1 over n because then I would just end up over here with the n in an exponential position on the left side, and that doesn't help me. I have to actually get the n down from its exponential position. So what we can actually do is take the natural logarithm of both sides of the equation. And if you remember this from algebra, that's wonderful. If not, then you're probably in good company. But here's what actually ends up happening. When you take the natural log of something to a power, then it ends up that this exponent comes down, and this is the same thing as n times the natural log of 1 plus I. That's one of the properties of logarithms. So now we're actually in business. Now we can divide the log of 1 plus I, and this is the formula, okay? The number of periods can be computed as the log of future value over present value divided by the log of 1 plus I. So let's see how we might apply the formula. Here's an example problem. If sales grow at 20% per year, how long before they double? Okay. Well, at first glance, you might say this isn't a time value of money problem because we don't really have interest involved here, and you'd sort of be right. Okay? But it really doesn't matter whether we're talking about money growing at a rate of interest or sales growing at a certain rate, or even something like in the biological sciences, the number of bacteria in a dish growing at a certain rate. The underlying mathematics is exactly the same. It's still the future value, present value, growth rate, and number of periods that you have to be concerned with. It's the same formula, really. So anyway, how would we solve this problem? Okay, well, we can apply the formula. N equals the log of future value over present value, and at this point some people would say, but wait, we don't know exactly what the present value and future value is. Nowhere up here did it say what the initial amount was and what the final amount is. That's true. They don't say explicitly, but they did say that it doubles. Now in some problems you'll be told explicitly what the values are, and if so, that's great. Plug them in. But here you're simply told that they double, and so that's really enough, because if you take the future value divided by present value and this one is double that one, then you know that when you divide, the outcome is going to be 2. And then of course over here we've got 1 plus the interest rate, so to speak. It's really a growth rate, but the math is the same. So 1 plus 20% is 1.2. So you got the natural log of 2 divided by the natural log of 1.2. We can certainly do that on either of our calculators. If we've got a graphing calculator, let's go back out to the main screen by pressing second quit. We can take the natural log of 2, and divide by the natural log of 1.2, and of course that gives us 3.8 years, which is what we're supposed to get. Or on a TI BA2 Plus, the key sequence would be just a little bit different. We would have to push the 2 and then natural log, so then that gives us the log of 2. Then we divide by the natural log of 1.2. How do you do that? Type in the number 1.2, hit the natural log button to convert it to its log, and now you can hit equals, and it'll divide those two numbers and give you the same answer that we had before. Alright, now a lot of people understandably don't really want to use this formula, although it's helpful to have it around just in case you ever need it and you don't have financial functions handy on your calculator. So this is what we would do. Okay, let's go ahead with our TI BA2 Plus, and here's our 5 time value of money keys. Let's go ahead and clear them out like I suggested before. We'll press second and then clear time value of money, and we can't put in the value for N because that's the unknown in the problem. We'll be solving for that. But for I, the interest rate per period, we're going to put in 20 because it's 20%. And then for present value and future value, this is where some people get a little bit hung up because, again, the specific values aren't given in this case. If they are, that's great, but what do you do if they're not? Well, again, you know that the future value is double the present value, and remember the thing about one of them needing to have the opposite sign. So present value needs to have probably a negative sign while future value has a positive sign. You can do it the other way around. You just can't have them both negative or both positive. So, and then the other important thing is that because they double, the future value needs to be twice the magnitude of the present value. So the easiest thing to do really is put in -1 for the present value and then put in 2 without the negative sign for the future value, and that's fine. If you had wanted to put in something else like -500 and +1000, as long as it's double, that would be fine and you'd get the same answer. But here you compute N and you get the answer you're expecting. Now if you do this on the TI-83, you go into Apps, Finance, Time Value of Money Solver, and you put in 20 for the percentage interest rate, probably -1 for the present value and 2 for the future value. Then you go back up here, put your cursor on N, push alpha and solve, and you'll get the 3.8 years, which is the correct answer to this problem.